Hi everyone. Hopefully your preparation is going well. These are the questions we are going to try in today's episode. We discussed these questions in our live workshop on arithmetic conducted on 25th of April. If you have tried these questions, then go ahead and watch the solutions and discussion related to it, which will be starting right away. And if you have not tried it, we'll recommend you to try it once before you watch the solutions. Before we start today's discussion, let me take a moment to introduce some fascinating courses at Mathoratory. Simply visit our website and check the plethora of options that we provide for CAT, GMAT, and other aptitude test preparation. We strongly believe in providing flexibility and convenience to students as per their requirements. Very recently, we have launched our live workshops for CAT and OMETs, which will be conducted every Sunday from 25th of April 2021. Every area of testing will be dealt in these live sessions. It will also include strategy sessions and special workshops on top MBA entrance tests for Indian B schools. In each of the workshops, we will provide live tests as well as live analysis of those tests for the specific topic which is being discussed in that workshop. Instead of purchasing the entire bundle, initially we are offering the option to register yourself for a single workshop. Just visit the workshops page under our courses and scroll down to get the option to register for the very next workshop that is going to be conducted. Let's now continue with today's video and have an enjoyable preparation ahead. I believe many of you fell in the trap. You have to understand the basic idea of percentages and the basic idea of allegation and stuff without knowing it. If you start applying it, you will always make these kind of mistakes. So many people asked me this question, but I'm getting 175% as an answer. I'm not finding that as an option. Are the options correct or something like that? First of all, you cannot even figure out what is the actual percentage change. You cannot figure it out. Okay, I'll explain why. And that is why I hope you can see in the question why the question is asking by what percent could the current average exceed the original average. It's not asking for how much the current average will exceed the original average. Now, why is it not determinable? See, the question tells us that the salary of each of the 25% of the members is doubled. Now, the salary of that group of members will depend on two factors here. So, salary of a group, any group, will depend on two factors. One is the number of members, and the other is the average salary of that group. Now, you know that one of the group has 25% member and the other group has obviously then 75% of the members. So the number of members are in the ratio 1:3. What you don't know is what is the average salary of each of the group. The question tells you that the average income of the entire family is 16,000. This doesn't imply that both the groups will have 16,000 as an average salary. So that is not mentioned. So what you can say is, because there is one group that is, if you look at the data, if the salary of each of the 25% is doubled, so if one of the group, the salary is getting doubled, there's a 100% increase in that group for whatever be the members or whatever be the salary, total salary of that group. And for the other group, the salary becomes 3 times. So basically it is increasing by 200%. So these are the two increases that we have of the two groups. We don't know in what ratio should we actually mix this, because the ratio that will be applicable here will be the denominator of the percentage. I mentioned this a lot of times. In allegation, always the denominator is applicable in the ratio. Now the denominator is the total salary of the group, not the number of members. Had the average salary of both the groups being equal, then the ratio of the salary will be equal to the ratio of the number of members. But as long as we don't know that, we cannot figure out the ratio of the salary of the two groups. So as long as I don't know this ratio, I cannot comment on this value. How much is this? But what we can always comment on is the basic idea of average. Whatever be this average, it should always lie between 100% and 200%. And hence the question is asking for what could be the current average. More than the original average. And only one option is in between 100% and 200%, that is 120%. So that is the answer for this question. This is a very nice question. I mean, there are a lot of variations that are developed on this particular idea. There are few mistakes which typically a student makes. I'll point them out first. For example, for question number 1, we know that B is starting t minutes late, that is fine, and meets A 5 kilometer ahead of X at the point Y. So A and B are meeting at this point, right? This point Y. So if A and B meets at that point Y, and B is late. So there are a couple of things that you can straight away say. At this situation, I don't care about this P2X region, because A is anyhow starting at the same time that it usually does. So I just focus my analysis on this X and Q region. So in this X and Q region, A is not late. So what does that imply? That A will reach the meeting point at the usual time. It's not late at all, right? So whenever A and B reaches every day, at that time A has reached X, right? B has not reached this point yet. The other thing that we have to understand is, because Y is the meeting point between A and B in this particular day. So when A reaches X, B should be somewhere behind Y, right? We don't know exactly where it is, but should be somewhere behind. Otherwise, how would they meet at Y? So only way possible is B is somewhere here, and A travels to this point and B travels to this point, and they meet. So that is how the meeting will work, isn't it? Because A is traveling in this direction, B is traveling in this direction. So this much we are definitely sure about, right? The data that we have is this section is 5 kilometers. And we also know that A and B are simultaneously at these points. So this is X and this is some hypothetical point. We are not sure about where it is. We also know the speed ratio. So we know that A is traveling with a speed of 20 kilometer per hour and B is traveling with a speed of 15 kilometer per hour. So the speed ratio of A and B is 4:3, right? So in a given amount of time, what I mean by given amount of time is, after reaching point X and this point, whatever that is, let's name that point R or something. So after reaching this point X and after reaching this point R, A has traveled to Y and B has traveled to Y in the same time period, isn't it? So because the speed ratio is 4:3, in a given particular time period, the distance covered would also be in the ratio of 4:3. So this will be, these two distances should be in the ratio of 4:3. But we already know this 4 is corresponding to 5 kilometers, right? So this 3 should correspond to how much? 3.75 kilometers. So you can use some scaling ideas and all. You can also calculate this simply as 3/4 of 5. So that is 3.75 kilometers. So this is the shortfall that B had, isn't it? Recall that earlier scenario. A had reached this point, and at that particular time, B was here. So B was shortfalling by how much distance? 8.75 kilometers. Now, if B was on time, then B would have reached this point as well, isn't it? But because B is shortfalling by 8.75 kilometers, so how much time is B starting behind? It should be distance divided by speed of B. We should take speed of B into account. You can very well do something like this. Let me just show that as well. So if B is traveling with a speed of 15 and it is t minutes late, so also convert this to hours. So this distance should be 8.75. This is what B did not travel, right? Because of being late by the time A has reached the point X. Or you can directly do this. But do remember that this time that we get is in hours if you do it in this way. So convert that to minutes by simply multiplying 60. So that's 4 times of 8.75. Simply double it twice. So double of 8.75 is 17.5 and double of that is 35. So answer is 35 minutes here. So that is the one for first question. Coming to the second part of it, now this is very interesting. I mean, you can definitely solve the second one using variables. I'm going to show you some method where you don't need any variable at all. I'll simply deal with the relationships. In this case, my main focus will be from P to X because B has increased the speed, isn't it? So what I mean by that is, intuitively you should understand one thing. Because B has increased the speed, B will reach the point X. So point X is the main focus every time. Even the information that are given. So in the first question, the information was relative to point X. For the second question, XZ. So that is also in relation to point X only, isn't it? X is the focal point because that is the point where A and B meet every day. So X is the focal point here. Now, because B has increased his speed on this particular day, B will reach this point X before A reaches point X, isn't it? He's traveling with more speed than what he usually does. So again, I mean, I'll just focus this time around more with this P region, but I will keep this Q region as well. I mean, this QX part, because that is the question, right? Find the distance QX. So this is what we are looking for. But then that is what we have to figure out, nothing more about it, right? So I just focus more on this P2X region. Also, what I'll do is I'll just take another hypothetical point, this R or something in this case. Don't confuse with the previous R. It's just a hypothetical point. And also this point Z, because that is their meeting point, right? Now, first thing, what is this R? Similar to the previous scenario, when B reaches this point X, P must, not A must be, sorry, I said P. A must be at point R, isn't it? Somewhere. I mean, we don't know, and we don't know too much about R at this particular point, but the time at which B reaches X, A should be somewhere at the somewhere between P and Z. Only then they could meet at this point Z, right? So this is very natural to understand. Another thing that we can do is, see, this time around, B is traveling with 6/5 of his speed, isn't it? Is increased his speed by 20%, right? 1/5 increase. So it's traveling with 6/5 of his speed. So in order to travel the QX distance, B will take 5/6 of the usual time, because that is the distance is constant, right? I mean, every day B travels from Q to X. Whatever time he takes to do that, in this time around, he'll take 5/6 of it, isn't it? Also, A has not changed his speed. Please understand that. So they usually meet at this point X, but this time A has only 5/6 of the time. So in 5/6 of the time, A has managed to reach this point R. That is what we have. That is what we have started with, right? When B reaches point X, A reaches point R. So P to R should be what? See, if A would have covered till X, that would have been the whole time. Instead, he has 5/6 of the time. So effectively, what we can say is this PR is 5/6 of PX. I hope this is understood, because he has 5/6 time to travel, right? So first thing, what I'm going to do is I'm going to draw some relationships here. So I know that PR being 5/6 of PX, I can say that PR and RX are in the ratio 5:1. So these are some ratio numbers. Okay, I'm not putting some values, exact values. I'm just putting some ratio numbers. So this is 5:1. That is what I mean by it. Now, after this, let's do another thing. After reaching this point R and X, A will cover till Z, B will cover till Z, and they'll meet here, isn't it? But this time around, A's speed of A is 20, but speed of B is 20% more than 15. So that is 18, isn't it? So that is in the ratio 10:9. So if I consider this part as 10 and this part as 9, how much are we getting this Rx distance as total according to this relation? So this is what I do. I deal with these numbers first of all. So this is 10, this is 9, the total is 19, right? But in the above relation here, we have considered this Rx to be 1. I'm doing nothing, just combining this relation with this relation. That's it. So according to this relation, this is 10 and 9, so total of 19, implies this should also be 19, and this should be 95 then. 5 into 19, that is. One last thing left to do. The focus is what do we need to find? We need to find the point, the distance QX, right? I've not yet used the actual data. I'll do that at the very last. So by the time, if you remember, by the time A covers the distance PR, B covers the distance QX, right? And according to our data, this PR is 95. So QX should be 9/10 of 95 because of this speed ratio. A is covering with the speed of 20 and B is covering with the speed of, or traveling with the speed of 18, right? So B will cover 9/10 the distance in a same amount of time because A and B has started from P and Q at the same time, right? That is anyhow given. Now, this is according to our data, right? Now, what is the disparity? I mean, what is the actual data? The only data available to us is this XZ. So this XZ is 5 kilometers, right? Now check it out. What have we assumed? So this XZ should be 5 kilometer. I'll just box this out. And we have assumed it to be 9. So we have to multiply 5 by 9. So effectively everything here have to be multiplied by 5 by 9, right? So even in this QX has to be multiplied by 5 by 9. Don't adjust the other ones. That is irrelevant. The only thing that is required is this. So simply calculate this one. So you have 5 by 10 is half, 95 ka half is 47.5 kilometers. So I hope this was understood. It's a fun question. A can do a work in 30 days, so time and work problem. B can do it in 40 days and C can destroy the work in 50 days. Okay, so whenever there's a construction, destruction kind of thing happening, same thing with pipes and cistern types as well. Whatever work has to be constructed for, that the same amount of work has to be destructed for as well, right? So keep the total work constant. But in this case, we have individual times given. So let us just assume the total work to be something. So total work, I'm assuming it to be what, 600 is fine, I guess. LCM of these three numbers. So A can complete it in 30 days. So A works with an efficiency of 20 units per day. This is units, the total work that is. So 20 units per day. B is completing this in 40 days, sorry, and hence has an efficiency of 15 units per day. Now C is destroying the work in 50 days. So has an efficiency of 12 units per day, but this is a negative efficiency. So I'm just putting a bracket just to visually understand this. I can put a minus also, same thing. These are the efficiencies of A, B, C, right? If A and B work together, alternating with C, that is A and B work on one day, C alone on day two, and so on. So one day A and B is working, then the second day C is destroying some work, right? Whenever this positive, negative kind of sequence is happening, I think we have discussed this earlier in lessons. I'll just detail this a bit. So suppose there's a pole or something which is 10 meter in length, and a frog is trying to climb this pole. Every second it goes 2 meter up, and then next second drops 1 meter. So it's similar, right? I mean, some positive and then negative. So this sequence is going on. So how many seconds are taken to for the frog to reach the top of the pole? So whenever you have this idea, just do this single jump. The single jump of the frog is of 2 meters, right? So keep that 2 meters aside. Keep 2 meter aside, the last 2 meter that is, and think about the remaining 8 meters. Effectively, this is happening in 1 second and this is happening in 1 second, right? So effectively, the frog is, whenever the cycle is completed, the frog climbs 1 meter in 2 seconds, right? In every 2 seconds, it's climbing effectively 1 meters. So for these 8 meters, the frog will definitely take 16 seconds. That is for sure. But in the next second itself, because it's climbing first, right? It's not dropping first. In the next second itself, it will reach the top of the pole. So effectively, that will be 17 seconds. So keep one positive part separate. The same thing we are going to use here. A and B working together will complete 35 units in one day, and C alone will destroy 12 units in one day, the next day, that is. So this cycle is of 23 units and of 2 days each, right? Now, what is the total amount of work that we are targeting? 600 unit. But as I said, keep one positive part aside. So if I leave out 135 units separately, so I'll be left with 565 units to be completed with this cycle. Now, I guess you can easily check this out, and 565 is not a multiple of 23. So it will not be a holistic number of cycles if you target 565. So what to target? Should we be targeting something below 565 or something above 565? See, if you go for just below, the thing is, you'll still get an answer. It's just that you will just work on it a little bit more. For example, if you think about, or if you just evaluate a bit, you'll find that 23 times 24 will be just below 565. So this will be 552 units. But the thing is, if you take 24 cycles of this 23 unit, then that is 48 days. That is fine. But then after 48 days are done, you have completed 552 units, right? The next time when A and B are working, they'll only complete 35 units in a day. So the total work is anyhow not getting completed. So C again works for it. So again, you're going to calculate for one extra cycle. So don't do that. So what you do is just, if it is possible that the cycle completely hits on this number 565, whatever it is, depending on the data, so then it is fine. I mean, then you don't have to worry about these kind of things. But then if it is not, then hit on the number or the multiple of 23, which is just above 565. So in that case, I mean, in this case, it will be 23 into 25. So 23 into 25 is 575. 24 square is 576. So 24 square minus 1 will be 23 into 25, right? 24 minus 1 into 24 plus 1. So that's 25 of these cycles, right? So that is how many days? 2 days cycle of 25. So that is 50 days. So this 50 days, we have completed 575 units. So this is done. Now, what is remaining? So we are left with 600 minus 575, and that is 25 units of work. Now understand this, after every cycle that is completed, first A and B is always working, right? So if first A and B is working, in one whole day, they would have completed 35 units. But we just have 25 units remaining. So how much time will A and B take to complete the remaining work? It will be 25 by 35, that is 5/7 of a day. So effectively, we have a total of 50 and 5 by 7 days. So option B is the answer. Thank you for watching us on YouTube. Hope you liked the video. For more such content, subscribe to our channel and hit on the bell icon for notifications. Do like the video and share it among your friends. Also leave a comment below for the video. As I mentioned at the start of the video, these questions were discussed in our live workshops. To watch more of these workshops, you'll have the option to take a free trial. Simply visit our website, select the live workshops from our courses, and enroll for a trial. Also check the plethora of options we provide for CAT, GMAT, and other management entrance test preparation at Mathoratory. We strongly believe in providing flexibility and convenience to students as per the requirements. You will have an option to either take a full course or learn exactly what you need to. For instance, if you plan to prepare one-to-one live with mentor, you can book sessions for only doubt clearing or even just for analyzing your mocks. Even for CAT preparation, if you don't need the one-to-one guidance, the mocks, the mock analysis, the workshops, or the GDPI, which are actually included in the comprehensive course, and you just want to train for specific topics of your choice, then simply select a capsule from these numerous options which are available to you. It will cover everything from basics to all variations and applications of the topic under study. Take a trial or book a demo with us and select the course which best suits your needs. Thank you for joining in and have a pleasant preparation ahead.